Okay, and it goes directly to YouTube, so it's kind of nice.
Live stream.
Okay, everybody. First up, we are now in the winter, so you'll notice some things different on campus. Your grades should reset. Now, in fact, I've gone ahead and taken the fall and fall tests and zeroed them out so that way they won't, the grade you see will be your winter grade. The other thing I'm going to do here as well, the next day or so, I was playing around with it earlier. I'm going to mute -- unpublish all the fall assignments and fall tests, so that way they don't even show up. That way when you go to look at your grades or you go to check an assignment, it's just the stuff for the winter. Okay. It seems that when I unpublish them, it saves the grades, but even if it does chuck the grades out, I've got your grades saved on a separate spreadsheet anyway, so we don't lose anything. It just becomes a pain in the butt later if we need to go back through and get back. Okay. But winter assignments are updated. Okay. Basically through till Christmas. Okay. So the next 3 weeks worth of stuff is up here and ready to go, so you can just kind of follow along. Our goal is to have 2 tests between now and the break. First one is next Thursday, not this Thursday, but Thursday after is when we'll have our first one. Then tentatively, we'd have one a week later. That's what the other teachers want to do. I'm not entirely sold on that idea on the grounds that, 1, I think week to week is kind of a lot, and 2, that would be the very last day before you all leave. And so, no other teachers are probably going to cram a lot into that day. So I might for our class get rid of this second test and just say push it till January, or change it to be a quiz or something. Okay, that way it's not so rough. Sorry. Partner test. Yeah. Make it something so it's not so intense there at the end. Other than that, this is everything to expect between now and the end of December. Okay? So it's kind of that nice short 3-week little fun time we have here.
Yeah, fun.
Well, it can be fun if we make it.
Yeah, of course.
Oh, by the way, too, who's gonna come to Star Wars?
I can't. I actually saw that.
Oh, you saw?
Like the entire basketball team in the game.
Well, I do want to point out it is 3 movies, and so we will be doing it, all afternoon. So if you can't make one, you can make the others. Go for it.
What? It's cool.
I posted. We're going to do a Star Wars movie marathon on December 12th, it's a Saturday, starting at 1, and basically we're starting with the 4th movie, A New Hope. We're going to do that one. And then the 2 after it, so Empire and Return of the Jedi, kind of back to back, because that week is when Force Awakens comes out. So all in preparation for that. So we'll see.
Awesome.
Doesn't it come out on
It comes out the 18th. Although some theaters are showing it early on the 17th. So that's just the way things go. Anyway, okay. But yes, so fun things like that
That would be awesome.
are available. So,
Is it in the AV? I guess in the AV center.
no, I'll be showing it in the Brown Auditorium.
Oh
So it's on the big screen.
Even better. The big
screen. Because they've got the fancy projector in there, and I think they have a DVD head up in there. And
wow.
I'll be popping in. I've got the copies I'll be showing are basically they're closest to the original theatrical release as you could possibly get. They all came from they were copies ripped from a 1980s Laserdisc version. They converted it to DVD. So they'll be a little bit different maybe than some of you have seen, but they'll be fun. They'll be good. Anyway. Okay, getting back to math. Trigonometry is what we're going to be studying basically all this winter trimester. we started talking about this a little bit about this before. Kind of that last week of school, we had touched briefly upon it one day in class. Specifically, we were going to do more about it, but then we had the free day, and then at that point, it just was like, okay, let's just make sure we're good for the exam at that point. Okay, but trigonometry is what we're going to cover. Okay, so basically, what we're going to do today is just kind of review the things we've gone over before to make sure you have a good sense of what to expect. And I'll also be kind of introducing a few new concepts as well, okay, as we move along. So, kind of trigonometry means the study of triangles. What we're actually going to be looking at is essentially angle relationships, and specifically how angles and the relationships work on an XY coordinate graph, okay? And eventually we're going to take all this and turn it into a function and explore how that works, okay? So it's essentially kind of the topics we're going to do is we're going to start off by looking at angle relationships. And then applying those as functions. As functions of x. Okay? So that's what we're going to be kind of after here. And it turns out there's a lot that goes on with this. Okay? You know, it seems sort of like an idea, oh, well, we're just looking at angles on a graph. Well, yes, but once we start getting into the core of it and how the relations between them, things get more complex. They get more complex very, very quickly. Okay, there ends up being a lot to this. So it's not just as simple as looking at angle relationships and just applying these function effects. Okay, but basically we're going to start off with, as I mentioned before the break, we looked at the difference between degrees versus radians. Okay, who remembers what's kind of the difference between the two? What is a radian? Start there. Anybody remember?
Based on the circle and the
Okay.
relationship between, what do you call it? I don't know English word, but
right. Okay, I got what you're saying.
the radius.
Radius, yes.
Yeah.
Basically, the difference between the two is they're both actually related to circles. Okay, degrees is basically an old way of measuring things. We saw it before. It's kind of the way you're used to doing things in like 5th grade, where you're looking at how much of a circle you move through, and it's based off of time, if you remember. Because if you think of the Earth's orbit as being a circle, it's very close to a circle. But if you think of it as being a circle around the sun, each day is 1 degree in that circle. Okay, and so that's why a circle is 360 degrees. It's based off of that and whatnot. It's kind of an old, clunky way of dealing with things. It doesn't work very nicely for our purposes, in math terms, for several reasons. Number one, it's based off of this arbitrary outside thing that has nothing to do intrinsically with a circle or with math. Okay, it's also very inaccurate because, as we know, does the Earth go around the sun in 360 days?
No, exactly.
That's 365. So the ancient Sumerians who came up with it got it wrong, although they were close. Okay, so there's that problem there. Plus 2, it's out of 360. How often in mathematics do we do things out of 360? Not very often, do we? We don't we typically stick with base 10, or when we're doing other bases, we like those bases to have some sort of meaning with the system. And 360, it doesn't really work out for us in that regard. So it's kind of an older, clunkier way of doing things. Okay, but we've got degrees, so it's out of 360. So angles are out of 360 degrees. Okay, a right angle is 9 degrees. Okay, and it's based off of the solar year. Okay, Radians, however, radians is a much better way of doing things because it's a much more mathematical way of looking at things. The radian angle system is entirely based off of intrinsic properties of the circle. Okay, so you're using a unit circle to describe characteristics of a unit circle, which is what we like. Okay, so the numbers you get out of the radian system, while they're confusing to see at times because it deals with a lot of the numbers have pi in them and fractions and whatnot, they're much better mathematically speaking because they actually deal with something that's unchanging. Okay, a fixed quantity, if you will. Okay, so it's the angles here for radians are out of 2 pi. Okay, now why 2 pi? Because that is the length of the circumference of a unit circle. A circle of radius of length 1 has a circumference of 2 pi. Okay, hence radians. Okay, the right angle is measured as pi halves, okay, or 1/2 pi, and it's totally based off of the radius of a circle. Okay, is what its system is based on. Okay, so that's the 2 different systems we use when describing angles. Any questions so far? Okay. Let's kind of compare the 2 systems together. So if I drew a circle up here, and I can do it fancy-wise. Ha. Whoa, too big. Yeah, that's good. Hey. Come on. We're not going to move? There we go. Okay, so we have a circle here. Okay. I'm going to go ahead and describe this circle to an xy plane. Okay. And draw the radius of this circle here. Okay. It doesn't actually matter how long the radius of the circle is. Okay. When you're thinking of it in terms of the radian system, the circle is always 1 radius in size, right? I mean, that's we don't care. That radius could be 50 centimeters. It could be 500 kilometers. It could be 20. I don't know, whatever crazy method, 20 paces. Who knows? Okay. But in terms of the circle, a circle is always 1 radius in size. So we can always think of the radius here as being 1. Okay. That means the circumference of the circle, if I were to start from this location here and work all the way around the circle and come back to that location there, I would have gone a distance of 2 pi r. But r is always 1. So what's the answer going to be?
2 pi.
Just 2 pi. Okay? So a full 180 or full walk around the circle is 2 pi. So this location right here is always marked as 0 or 2 pi because you're going around it. Okay? It'd be equivalent of saying 0 degrees compared to 360 degrees. What happens when you've walked around 360 degrees? You've gone right back to where you started.
It's like displacement physics.
Exactly. So I can say this is also 0 or 360 degrees. Okay? Any particular angle on a circle then in radians, okay, is measured by how much arc you've moved through. How much of the circle circumference you've moved through. Okay? So, where it's pointing right now, I've moved through an 1/8 of the circle, if you will. Okay, at this point here. What's an 1/8 in degrees? So if I do, what's 360 divided by 8? Let's start there. It's 45. So if this were a 45-degree angle, okay? Okay, its equivalent in radians would be the same sort of way. It's an 1/8 of whatever 2 pi is. What's 2 pi divided by 8?
Pi over 4.
Pi over 4. Okay, so I would say that there is pi over 4. What that pi over 4 is measuring specifically is it's measuring this distance, this arc distance here, okay? So the distance from where I started to where I got in here, that arc is pi over 4 units in length, okay? And so if it happened to be, if you need an actual physical measurement there, you can think of it as pi over 4 radiuses, if you will, okay? That's how long it is, okay? Hence why it's called the radian system, okay? So it's pi over 4 radians, okay? And you go through and fill in the circle accordingly based off of this, okay? And in fact, an exercise we're going to do tomorrow, okay, in preparation for the weekend. So this is 90 degrees. This is 180 degrees. This is 270 degrees. Okay. In fact, what we're going to do in preparation for Saturday, because I'm actually going to give you a very short quiz in the morning on Saturday on this thing, okay, is we're going to fill out the circle with all the regular known used locations in terms of radians, okay? Because as we go through here, as you'll discover, a unit circle there, radius 1, we can find many more locations like pi over 4 that make sense, that are easy, recognizable, and have meaning to us that we will use over and over and over again, okay? So we end up filling in that circle. Then what we can also discover is because we're putting in xy plane, we can actually fix coordinate values at every location along the circumference of the circle. Okay, and so that ends up being important to what we end up doing with trigonometry later. But right now we're just going to concentrate on today on the angle relationships and how radians and degrees work. Okay, but so that's essentially what you're doing with the unit circle. Okay, or with this with the radian system. Any questions on how that way of measuring things works out? Yeah.
If we measure the distance of the circumference that we met, how? That's not angles, right? Like that's.
Well, the thing is, you're absolutely right. Okay.
Or,
technically, what
yeah,
we're measuring here
is how many radians?
Is this distance right here.
Yeah.
Okay. But we can convert that or think of it as being an angle because remember, if you remember your geometry, a inscribed angle from origin of circle to the outside has the same measurement as however much arc you've moved through, okay, angle-wise. So, this angle here, okay, if that's a 45-degree angle, I've moved through 45 degrees worth of arc, okay?
That makes sense.
And so that relationship preserves when doing it with radians as well. I can describe that angle as being pi over 4 radians in measurement because it's moving through pi over 4 radians of arc.
So we say radians.
Radians.
How do we like note that down? Is it R?
No, you just actually typically you don't do anything. You just leave it as pi over 4.
Oh.
Okay. Yeah. There's no degree symbol. There's no. If you want to be fancy, you could write pi over 4 radians after everything. But the vast majority of times when you write these things out, you just write out what the answer is. Okay. You say the angle is pi over 4. Okay. Because again, pi over 4 here is an actual distance measurement.
Yeah.
Okay.
And yeah. Cool.
All right. Any questions there? Okay. Typically speaking, when we measure angles, we measure them counterclockwise. That is, we start from here and we go in the opposite direction than a clock around the circle. Okay. What happens if we measure the angles the other way around? If we do it clockwise, how would we treat the angles?
Much bigger.
So, let's say I did a 45-degree angle in the opposite direction. Okay. So instead of going around clockwise, instead of going around counterclockwise, I go around clockwise like that to get there. Okay. How would I treat the measurement of this angle right here?
It'd be bigger than 360.
Okay, so one way I can think of it is treating it as just going around the regular way. So in this case here, we won't make it. We won't say it's bigger than 360. because we'll say we're only going around the circle. We're starting here and we're going around until we hit that location there, okay? So I can measure it that way, okay? In which case then, this would be, let's see, since this is supposed to be the 45-pi/4 angle, okay, it would be pi/4, 2pi/4, 3pi/4, 4pi/4, 5pi/4, 6pi/4, 7pi/4 would get me there. And then degree-wise, it would be 270 plus 45, which is what? 315. Okay? So that's one way I can measure it. But what's another way? What if I, instead of thinking it still in terms of going around the circle that way, I go backwards? Typically when I go backwards, what happens? It goes negative, right? So another way I can think of it is I can make the angles negative, and I can make the radial measurement negative. And what it means in that case is just I'm going around the circle in the opposite direction.
So the shortest way. Okay.
So I could also write this as minus pi/4 or minus 45 degrees. So if you see a negative angle, all it means is that I've gone around my circle, or I'm measuring my angle in the opposite direction. Okay? So instead of going the counterclockwise we like to go, we decide to go clockwise instead. Okay? And that's all it means. So notice how these here are equivalent. Okay? They're equivalent measurements. When you have such a relationship like this is known as being coterminal. Okay? Because the angles end at the same location. Okay? The values of the angles are different. One's 7pi/4, the other's minus pi/4. But at the end of the day, you end up in the same location. So when that happens, you describe the relationship as being coterminal. Okay? Any questions about that? So when you see a negative angle, that's essentially what you're given there. Okay?
So coterminal is a negative angle.
Could be a negative angle. It's actually anytime when it's anytime you have an angle two angles that end up at the same location. Okay? So for example, I could add 2 pi to this guy right here and have another coterminal angle at the same location. So 7pi/4 plus 8pi/4 would be what? 15? Yeah, 15pi/4. So I wrote the angle as being 15pi/4. That would be the same angle as 7pi/4. So they would be coterminal as well. What that would mean is I started here, went around once, then came around again. Okay? And there's no reason why you can't measure angles that way. Okay? It just means I went around more than once. So, and you could do that, by the way, with degrees as well. Okay? So we know this is 315 degrees here. Well, if I go around my circle once, then come to this location, it'd be 315 plus 360, which would be 675. So I could say this angle is 675 degrees. Okay? And it'd be the same as if the 315 or the minus 45. Okay? All it means is I've just gone around the circle multiple times. Okay? They're all the same, they all represent the same angle, so therefore are known as being coterminal. Okay? Any questions there? Okay. Some of this stuff should be reviewed, like for example, if I say what are supplementary angles, they're angles that do what? Add up to 180. If I say they're complementary, they add up to 90. Okay? Same thing here. By the way, those terms exist for radians as well. You just change it from 180 to pi, and from 90 to pi/2. Okay? Any problems? Nope, all good there? Good. Okay. The next thing we want to know is we want to have a nice conversion between degrees and radians. Okay? Because that comes up from time to time. Especially at the beginning here while you're still getting used to how radians work. By the way, kind of later on, when we do this, when we do exercises or when we start to move further through trigonometry, we're going to basically be getting rid of degrees. We're going to stop using degrees and concentrate solely on the radial system. Okay? And in fact, next year, those of you who take who stick around and take calculus, or when you take calculus in college, you will never use degrees. Okay, I've been doing calculus for a very long time, and I can tell you right now, I may have seen 2, maybe 3 problems total that were in degrees instead of radians. So it's something to keep in mind. Okay, you just won't. We just stop using that at a certain point because again, the radian system basically makes more sense in mathematical terms. Okay, so conversions when you need them. Okay, degrees to radians. Okay, is you're going to have your degree measurement, and you're going to multiply it by pi over 180 to get the radian measurement. Okay, so an example of that, if I had, give me a good angle, doesn't matter what it is.
47.
47. So we had a 47 degree angle. 47 is actually a terrible angle. But we had a 47 degree angle and we wanted it converted into radians. It would simply just be 47 times pi over 180, which gives me 47 pi over 180. 47 over 180 does not reduce. And 47, I believe, is actually prime, so I don't even think it reduces further than that. That's as far as you can go, okay? But that's the general idea. That's what you would have, okay? If we did a more sensible angle, so maybe something like, 50 degrees, okay, 2 radians, it would be, we would do 50 times pi over 180, and that'd give me 5 pi over 18. And so that would be the measurement there, okay? So notice I did reduce the fraction when I did multiply it down. You do want to do that when writing angles in terms of radians, okay? We like them to be as simplified as possible, okay? Normally I don't fuss at you too much about simplification. This is one I am going to be like, simplify it. And that's mainly done because, as we'll see later on, like I said, when we start to look at this in terms of the xy planes, known locations are always written on that in simplest form. And so if you can find, if your thing ended up being one of the known locations, you'd want to know that, okay? And so, 5 pi over 18 is not a known location. I shouldn't say known location. Actually, it does correspond to xy values. They're just not very easy to remember, okay? And finding them would be a pain in the neck, okay? In fact, the book that's propping up the iPad actually has the tables in it of locations of like where 5 pi over 18 is on that circle, okay? Yeah?
The formula for making radians from degrees, is that 2 pi divided by 360 and then simplified?
Basically, yeah, and it just simplifies down to pi over 180.
So that's how you derive it. Sweet.
You can think of it that way, because 2 pi and 360 are the same, and so
sick. Okay.
we're thinking of it that way. By the way, to go from radians to degrees, you basically just invert that.
Yeah.
Okay?
Sick.
So, for radians to degrees, or it's the radian measurement times pi over 180. And that's how you get your degrees. Okay? So,
Isn't 180? No.
yep, pi over 180. Okay?
So
And it's the same exact thing as above, so which was, wait, did I write this? No, it's 180 over pi.
Yeah, okay, perfect.
Yeah, sorry.
That's fine.
Thank you. Yeah, it's the same thing as above, you just invert the fraction. Okay? So, equal to degrees. So, if I had let's go with a radial measure. Let's do one that actually corresponds to a known location. So let's do 5 pi over 6 radians, 2 degrees. Okay? That's going to be 5 pi over 6 times 180 over pi. Well, things cancel here, right? Like the pi's cancel, which is good. Does the 6 and the 180 cancel?
Yes.
Yeah. 6 goes into 180 30 times, right? So it's 5 times 30, which is 150 degrees. So 5 pi over 6 is 150 degrees. Okay? They're the same measurement there. But that's how you would reverse, go from radians to degrees. Okay? By the way, these conversions work even when you're dealing with negative angles or angles above 360 or 2 pi. Okay? So if I needed to know, for example, what, just as a quick example, if I needed to know something like 500 degrees in radians, I do 500 times pi over 180, start cleaning that up. So it would be 500 or 50 pi over 18, which cleans up again to 25 pi over 9. And that's as simple as it gets. Okay, and then you would just have to determine, well, okay, where's 25 pi over 9? What's that equivalent to on the circle as we know of? By the way, there's a way to do that as well. When I have things that are bigger or smaller than 360, or that are bigger than 360 or smaller than 0, or bigger than pi over 2 and smaller than 0, I could find what they should be on the unit circle by either adding or subtracting 360 or 2 pi to it. So in this case here, since 25 pi over 9 is greater than 2 pi, if I wanted to adjust this to know where it is on the unit circle, or on the circle normally, I would subtract 2 pi from it. Okay? So I would take 25 pi over 9 and subtract 2 pi from it. And whatever answer I get, that would help me determine where it is. Which would be, let's see, 18 over 9. So 25 minus 18 is what, 7? So it's 7 pi over 9. So it's equivalent to that location on the circle, which is not an easy location to have. So it's not a nice location. But it is one. Okay? So notice, basically, I just subtracted 2 pi from that. So kind of writing that down as a rule, okay, for angles greater than uh, 360-2 pi, okay, simply subtract 360-2 pi until the angle is between 0 and 360-2 pi. Okay? So by the way, had I subtracted 2 pi here and still end up with an angle that was bigger than 2 pi, I just repeat the process. Just subtract 2 pi again. Okay? Likewise, okay, for angles less than 0, simply add 360-2 pi until the angle is between 0 and 360-2 pi. Okay, so we saw an example here with 25 pi over 9. Okay, and figured out where its coterminal was. Let's do another example. Let's say I had minus 3 pi over 4, and I wanted to know where that was on the circle between 0 and 2 pi. Since it's less than 0, I would add 2 pi to this. So I would add 2 pi to it to figure out where it would be. So that's 8 pi, so this should be 5 pi over 4, actually. Same location. Okay? Everyone see that? So if I'm actually drawing this out on a circle, negative 3 pi over 4 is going to be over here. And note, that'd be the same as doing this way. They're equal to each other on that circle. They're in the same location. Okay? So it's a way you could figure out how those coterminal angles work. Okay? Any questions there? All right. So for tonight, because we're just about out of time, I wanted to let you guys get to your next class. For tonight, all you're really going to be doing is just messing around with these angles. So some of it is going to be, just adding, subtracting. Some will be finding complements and supplements. Some will be, figuring out the coterminal angles. Some will be converting from 360 to 2 pi, etc. Okay. A few too will have to do with what quadrant the angle might be in. And again, just draw the xy plane, and if you go back, we talked about basically right here, if it's between 0 and pi over 2, you're in the first quadrant. Between pi over 2 and pi, you're in the second quadrant. Between pi and 3 pi over 2, you're in the third. And so on and so forth. Okay? So it should be something you can easily figure out. Okay? All right, everybody.
Thank you.
I will see you mañana.